Ladies and gentlemen, my name is Scott Tyson. I'm a Senior Business Development Manager for Structural Technologies. We offer assessment engineering service, product solutions, and also have via our umbrella company an installation arm. So we're a full service company. What we're talking about today, has anyone utilized FRP for column strengthening on previous projects? We got one hand. We got two hands. There might be a prize for participation as we go, so just letting you know. All right, that's what I like to see. The columns you see in the photo here originally by the engineer were specified for steel jacketing for their confinement and strengthening. Through a process, it was determined that FRP, fiber reinforced polymer, or CFRP, carbon fiber reinforced polymer, was a suitable solution offering advantages over the steel jacketing. That's what we're going to endeavor to talk about in 25 minutes today. We do have an agenda featuring background, little comment on design, the VE option for the FRP, and also installation summary. From a background standpoint, the project we're profiling, if anyone's familiar with Sacramento, California, there is a highway that runs along the bottom of downtown. It's US Highway 50. It was constructed back in the 60s, and they did a substantial upgrade featuring bridges, adding a carpool lane. I'll point it out later, but it's a center area that was open where they added column and additional lane. The owner, Caltrans, California Department of Transportation. We partnered with Flatiron Construction WSP engineers for a total of a $430 million project award with a 4-year time frame. Again, pointing to the map, this is just below downtown on Highway 50. We had two locations. We had the South Park Viaduct, and then we had the 15th and 16th Street Viaduct. Now, I'm going to profile one of them because they're not exactly mirror images of each other, but they're awfully, awfully close. Calculating it up, 48 plus 24, if my math is correct, that's 72 total columns. You want to retain that fact. That's going to come into play later in the presentation. It is a cast-in-place box girder. On this particular side, on the 15th and 16th side, 42 columns, 7 bents, 6 columns per bent, 4-foot diameter columns. However, the columns, as you can see from the renderings, were not cylindrical top to bottom. The last 10 feet at the top had a flare. That's going to come into play in a little bit. With regard to why we need strengthening on columns, has to do with the modes of failure. I know this may come as a shock to some of you, but California is a seismically prone area, right? Occasionally there's an earthquake. I used to have a boss who made jokes about hurricanes or earthquakes, but he lived in North Carolina. I said, you get hurricanes every year. I get an earthquake every 30 or 40. I just kind of like my odds a little bit better. But in the presence of a seismic movement, we can experience shear failure from the lateral motion as shown in photo 1. The middle photo, confining failure, usually has to do with the fact that the application of steel reinforcement in the 60s is not quite up to the code standard as it is right now. So if you're lacking confining steel, hoop steel, you can get a confinement failure as shown. And then the last failure mode is lap splicing, when we have different rebars lapping over the top of each other. If you look to the top of that last photo, you can see some 45-degree cracks. What's happening is the bottom steel is moving at a different rate than the top steel, causing that lap splice failure. Enter the steel jacket. Does anyone have any experience with utilizing steel jackets on their projects? Okay. So in this case, we're talking a 1/2-inch thick jacket from the very bottom to the very top, all the way through, designing for the maximum force that might be applied. Confining the column, giving you better performance. Now, let's look at the application of steel jackets. You've got two pieces, two halves, coming together. They can be several feet long. They are brought together by means of welding, and that would be welding on vertical joints as well as horizontal joints. With the project in question, when I mentioned the flare on the top of the columns, while steel can be fabricated to accommodate that, it can be a little challenging. I dare say there might be an upcharge for that. When you get the steel components to the site, you're hoping that the edges match up nice and even and they're not offset one way or the other, complicating the welding process. We're all aware of material availability, supply chain issues, raw material issues. This can lead to extended lead times. In this case, it was 12 to 16 weeks out on the steel, and that's a conservative estimate. I mentioned fit up, I mentioned alignment. What about weight? You're going to have to likely have some sort of lifting equipment to place these steel shells. God forbid they fall, they're quite heavy. Piece of carbon fiber. I don't even need a hard hat. If this were steel, that might have turned out a little bit differently, be that as it may. So steel is also known to corrode. I know some people think that's a fallacy, but it does happen. These are considerations depending on your location. So what about the FRP? Well, let's go through the process first. This project was design-build. Design-build, to a certain extent, can allow for creativity, can allow for consideration of alternative means, and can allow for optimization. What do I mean by that? I'll show you in a minute. We paired with the construction team that was willing to embrace a new idea. The gentleman just before me said, don't be afraid if it's new. You know, we don't drive the same cars that we drove in college, do we? Maybe some of you do, I don't. Sometimes new has benefit. Along with the design team being reasonably engaged in the idea of pursuing this, we approached the owner and said, we have an option, it is viable, it could potentially provide schedule benefit, could potentially provide cost benefit. Would you be willing to consider? Throughout a series of discussions, all of which occurred before my tenure with the company, so I have a working knowledge of this, everyone came to the conclusion that it was viable to embrace the alternative technical concept. So we have two approaches as to how to go about putting this solution into play. We could do a steel equivalency, top to bottom, how much carbon fiber fabric do we need to equal the steel from top to bottom. But based on the performance criteria provided by the engineer shown here, we looked at optimizing based on the performance criteria, addressing this from top to bottom. We also had to account for the plastic hinge at the middle third. Can anybody see what's happening with the rebar in that circled area? Lap splice. Well, wait a minute. We just showed you a picture where lap splice is of concern if there's not enough steel there. So that's an area we might want to focus on from a strength perspective. We utilized a modeling software called SAP 2000 to run calculations on the performance of the original design. Where do we need to strengthen? We took the plastic hinge into account, and our lead engineer said, well, the max moment that's demanded in that condition does not occur at the plastic hinge. It occurs at the top of the column. But we still need to address where the plastic hinge is because of the lap splicing and the known amount of steel that's present in that column. So what do we come up with? This is where we talk about optimized design. And I'm not sure because I can't really see from here, but if you can see the callouts on the right, this is showing the placement of the carbon fiber fabric, the FRP, where on the lower level we have fewer layers. However, in the lap splice area where the plastic hinge is, we have up to 6 layers present. That's where our force is going to be. That's where we want to concentrate for safety. So if we've got 3 layers on the top, 2 layers on the bottom, more layers in the middle, what benefit is there to doing this optimized design to the DOTs, to the clients? What does this mean in the grand scheme of things versus a half-inch steel jacket top to bottom? It means less material. Bear in mind, the installation crew gets paid for every layer they wrap around there. It's less labor to do the install, and the performance criteria is met. Now we get into schedule benefit. Every layer of material has a cost associated with it. We derive a cost benefit, but again, getting the performance that we seek. Kind of exemplified it already, but FRP is considerably lighter, easier to handle. We calculated an advantage in the magnitude of 10 to 15%. We didn't need a big crane to lift heavy steel and place it or deal with any safety issues that might result. And I apologize, folks, I used to be more on an architectural side with a previous company. And I used to joke that architects sometimes don't draw straight lines. In this instance, the engineer doesn't design a circular column. There may be geometry. This will readily adapt to geometry within reason. And from a long-term standpoint, we don't have a corrosion issue or a degradation issue with FRP. Ironically enough, one of your peers asked me last night, he said, well, we have areas where we're considering FRP, but there are transient people that are in those areas, and sometimes they start fires. And we're afraid versus a steel jacket, which does not readily accept flame, that they might cause this to catch fire or try to light it on fire. I said, well, if I told you that there are a variety of coatings that can be applied over this, either for aesthetic purposes, we have cementitious coatings for durability. We even have fire-rated coatings for durability. And I said, if you had a fire-rated cementitious coating over the FRP and it looks like concrete, most people are going to look at that and go, well, it's concrete. I'm not going to mess with that. So there are a variety of finish options with regard to the FRP. Now, I want to really have you focus on this slide because sequence, this caused me to really stop and look. I thought this was very interesting. We have to wrap the full height of the column. Can everybody note where it says phase 1 and phase 2? Well, phase 1, we're starting about 3 feet above the ground level and going all the way to the top of the flare. Okay? To make everybody comfortable with the application in the flare, there was a mock-up produced. If you have concerns, I strongly recommend a mock-up. It's a lot easier to prove it out on a smaller, less expensive face than to fully commit to the project and find out, well, maybe we missed something. Mock-ups do have benefit. But why do you suppose we started at plus 3 feet and went to the top, and then on the 4 foot below grade phase, that was done after the fact? What do you think the rationale was for that? Very close to it. It has to do with access. If we dug the 4 foot hole at the base of the column and then we're trying to go from the footing all the way to the top, I'm going to have to put a guy on a boom lift to get to that column unless I bury back the hole. It just made a lot more sense since the original ground was in place to start 3 feet, run to the top, then let them dig the hole and then tie back in. I thought that was a heck of a neat approach on the way to do this. It got the work started quicker and, again, eliminated the need of 3 boom lifts at X amount of dollars per day, which is going into the bid. We're cutting costs down there. Now, I have been in a variety of commercial construction applications over many years. Prep is generally essential, and prep should not be shorted. The better your prep, generally the better your outcome. What we did was mechanical grinding on the existing columns, and we were looking for what is called a CSP, or Concrete Surface Profile 3. I'll ask this a different way, is anyone not familiar with CSP as a standard? And I don't mean to put anybody on the spot, I'm here to educate. For those who may be shy in raising their hand, there's a chart showing CSP levels. We're talking just above Costco polished concrete all the way to the surface of the moon. Depending on what your application is, you may need a more aggressive prep to get the proper bond that you're looking for. Just so you know, this chart is readily available via the good old internet. That's where I got it. And the International Concrete Repair Institute, I think for $110 or something like that, will sell you a rubber chip set on a chain set that has all these surface profiles on it, if you like to be tactile. Another thing with installation process and prep, primers are generally used where they're specified. They need to be used. The other thing is, and I took this from another job, that first photo, you see the tear out at the bottom of the column. We utilized our epoxy to do the repair on the bottom of the column. Now, some people say, well, why don't you just use a repair mortar? That is an option, but if you've got a time-critical schedule and you patch that column with a repair mortar, and on the bottom of the bag it says, you need to wait 28 days before overcoating it, your schedule just got nuked. Just that easy. Or, as my operations manager will say, that repair, if it's cementitious, needs to be below 4% moisture content before I can put another layer of epoxy over it. The beauty of using epoxy for the repairs, we can go over it within hours. It's the same stuff. It's all compatible. And believe me, I've lived a lot of lives on the issue of compatibility of materials. The middle photo, the machine that you see, is called a saturator. It literally takes this fabric through a series of rollers and then through a bath of epoxy. It completely saturates top and bottom without fail. Got a lot of love for my fellow human beings, but if you're trying to hand apply this, I told a guy one day, I said, Monday morning at 10 a.m., the hand applied guy is doing really well. Friday afternoon at 3 o'clock, he may not be as diligent in doing his hand application for whatever reason. The beauty is the saturator gets it 100% every time. We impregnate. The saturator has a take-up roll. It's brought out to the condition the material is installed. Once the material is installed, they use a rib roller. It's a metal roller with spikes on it to properly set the material in place, remove any air bubbles that might be there, and then the photo on the right is an example of the top coat that the owner selected for the condition. Middle photo, that's an example of what I spoke of earlier, working from 3 feet up to the top, then digging the hole, then tying the FRP in. It just makes sense, and the right photo showing all the way down to the footing. Nice, clean, efficient. Little video of the guys on a scissor lift, going back over, smoothing it out, making sure they don't have any wrinkles, air bubbles, or holidays, and a whole bunch of columns, all strengthened. And a lot of trucks, ironically enough. Find that on job sites pretty regular. So in summary, we calculated a cost savings versus the steel jackets in excess of $3,000. Who remembers how many columns total we had? 72. I got a prize for you. We got a guy who's paying attention at 4:30. That's great. I love it. 72 times $3,000 without whipping out your iPhone. It's a little over 200 grand. For those people who are charged with making decisions and seek to maybe save a little money for the department without taking away from the performance and the lifespan. If you went back to your department and said, hey, I think we could save $216,000, would that be well received? Would they be happy with you on that? There are some contracts constructed where if the contractor brings in a VE option and it's accepted, they might even see a benefit on that from cost. We're making the cost more competitive, and we are still addressing the situation to the greatest extent possible, giving you your life. I mentioned durability previously. I mentioned the ability to accommodate odd geometries. And from a fabrication lead time, we talked about 12 or 16 weeks to get the steel. I get to carbon fiber this month and get going. And we're all in the construction arena, and we are never behind schedule. Everything arrives on time, and nobody damages anybody's previous work, right? The next trade doesn't damage the previous trade's work. These are absolutes in construction if you're not aware. So, folks, that's pretty much what I've got. We have a booth out in the hall. Be more than happy to talk to you about this to a greater extent. Years ago, when I worked at home, I had to deal with kids in the background making odd noises when I was on business calls. The odd noises you'll hear nowadays are my furry alarm system. So I just want to let you know, if you hear odd noises when I'm on the phone, that might be what the case is right there. And somebody said, you have 4 corgis. I said, hell, if you squish them all together, it's one full-size dog. Squish them together, it's a golden retriever. That's all it is. On behalf of Structural Technologies, thank you all for your time. I greatly appreciate it. Hope this was helpful, and we'll wish you a good afternoon, good evening.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.